Assalamu alaikum, my dear students. Welcome to your chemistry second paper class once again. Today I will discuss about oxidation and reduction reaction, that is redox reaction. Already you have gathered some knowledge about redox reaction in previous class, but today also I will discuss in detail about these redox reactions and also extra things related with redox reactions. At first, we have to know what is redox reactions. Actually, redox reaction are those reactions in where oxidation and reduction, both reactions are involved. Oxidation means the reaction in which electrons are released or loss of electrons occur is called oxidation reaction. And reduction reaction is such type of reaction in which electrons are received or grabbed or accepted, etc. is called reduction reaction. In our sentence, we can say oxidation is loss of electrons and reduction is gain of electrons. Sometimes we will be confused, especially in exam time, we will be puzzled. Oxidation is gain of electrons or loss of electrons. For this, you can remember these two terms, oil and rig, where oil means oxidation is loss of electrons and rig for reduction is gain of electrons. Then you can easily remember actually oxidation is what? Loss of electrons or gain of electrons. So easily by this way we can remember oxidation is actually a loss of electron. That means the reaction in which electrons is released and reduction is reaction in which electron is accepted. And this oxidation and reduction always occur together. Now, redox reaction. This term redox is actually a short form of oxidation and reduction. Now we will follow an example and where we will actually see how oxidation and reduction both reactions occur in a equation. Follow here. Here iron reacts with nickel nitrate solution and produce ferrous nitrate aqueous solution and nickel. So at first we have to observe which type of change or what type of change of oxidation number is happened in a reaction. Follow here. Here before the reaction, that means in reactor side, the oxidation number of iron is 0, the oxidation number of nickel is +2 and nitrate -2. And after the reaction, the oxidation number of iron becomes +2, nitrate -2, same as before, and nickel 0. So we can see here nitrate is remain unchanged, but oxidation number iron is converted into +2 from 0 and nickel ion is converted 0 from +2. So now we will discuss about here. The iron is converted from 0 to +2. That means iron releases 2 electrons and converted into positively charged ion, that is iron +2. So here loss of electron occur. So here iron actually oxidized because here iron releases 2 electrons. That means loss of electrons happened. For this iron is oxidized here. Although we can understand in another way that the oxidation number is increased. Always you have to remember that in oxidation reaction, oxidation number is always increased. Follow here. Here oxidation number increased 0 to 2. So here oxidation number is increased. So we can say there oxidation reaction occur. On the other hand, here nickel is converted from +2 to 0. That means nickel accepts 2 electrons and converted into neutral nickel. So here acceptance of electrons happen, that means gain of electrons occurred. So nickel ion actually here reduced. And also we can find this in another way. The oxidation number of nickel is decreased from +2 to 0. So nickel ion is reduced here. So one more thing we have learned, that if we find the oxidation number, if we find the change of oxidation number, then also we can easily identify which one is oxidized and which one is reduced here. In oxidation number will be increased, and in reduction reaction, the oxidation number will be decreased. Now we will find out about the oxidizing agent and reducing agent. What is reducing agent? Actually, in a reaction, there are present more than one reactants generally. So among the reactants, the reactant which helps in reduction of other reactant is called reducing agent. The reactant which helps in reduction of other reactant is called reducing agent. But that reactant itself oxidized. For example, here follow the equation. Sodium reacts with chlorine, produce sodium chloride. What is the oxidation number changes? Here sodium is 0, chlorine 0. After the reaction, sodium is converted into +1, chlorine -1. That means oxidation number sodium is increased and oxidation number chlorine is decreased here. So the sodium is oxidized and chlorine is reduced. Now sodium is oxidized. Who helps in this oxidation? Chlorine. So chlorine is oxidizing agent, but chlorine itself reduced. I hope understand you clearly. Again, oxidizing agent is what? The reactant which helps in oxidation of other reactant but itself reduced is called oxidizing agent. And the reactant who helps in reduction of other reactant but itself oxidized is called reducing agent. So here easily we can understand that if sodium is oxidized, so oxidizing agent will be chlorine, and if chlorine is reduced, then reducing agent will be sodium. Now generally an equation of a reaction can be written like this way. A reacts with B and produce A ion and B ion. Here we can see A is converted into A cation and B is converted into B anion. That means oxidation number of A is increased and oxidation number B is decreased. Not only that, A releases electrons and B accepts electron. So easily we can understand, in A oxidation occur and in B reduction occur. That means A is oxidized, B is reduced. But it is very much clear is that in a redox reaction there are actually two parts: oxidation reaction and reduction reaction. So in one part or half reaction is oxidation reaction and another half reaction is reduction reaction. So in a redox reaction, the part in which oxidation occurs, that is called oxidation half reaction, and in a redox reaction, the part in which reduction reaction occurs, that part is called reduction half reaction. So oxidation half reaction and reduction half reaction togetherly we call redox reaction. Follow the example. When sodium reacts with chlorine, produce sodium chloride. So here sodium is oxidized. We have seen sodium is oxidized and chlorine is reduced. So sodium, when converted into sodium ion, that is oxidation half reaction, and when chlorine is converted into chloride ion, that is reduction half reaction. And sodium is reducing agent and chlorine is oxidizing agent. Now my dear students, I hope you clearly understand about the redox reaction, about the change of oxidation number, reduction number, and oxidation number, and also you can easily now find out which one is oxidizing agent and which one is reducing agent. Now, following this redox reaction or using the mechanism of redox reaction, there are different types of electrochemical cells are prepared. In today's lecture, I will discuss such type of electrochemical cell, that is galvanic cell, or also it is called Volter cell or Daniell cell. This is also very important electrochemical cell, and also you have this is familiar to you because you already heard about this electrochemical cell in previous class, but still I will discuss about more in my today's lecture. So listen carefully. So before the discussion of mechanism, at first I want to discuss about the construction of this electrochemical cell. So let's see how can we prepare a Daniell cell. Follow here. In this picture we can see two electrolytic cell. Yes, here actually two half cells are here arranged separately, but they are also connected. So this is one half cell. Follow here, this is a electrolytic cell, and here is kept 1 molar zinc sulfate solution, and this is a metal plate made of zinc. Zinc plate is immersed in zinc sulfate solution, and here copper plate is immersed in copper sulfate solution, 1 molar copper sulfate solution. Now, according to electrochemical series, we know that the position of zinc is upper than that of copper. So zinc is highly reactive than copper. So here zinc acts as anode and copper acts as cathode. Now, so what is anode here? Here actually zinc plate immersed in zinc sulfate solution. This total package is actually acts as anode, and here copper immersed in copper sulfate solution. This total package acts as cathode. Now these two metal plates are connected by a voltmeter using copper wire, and this is the actually outer circuit through which electrons will be flowed, and the electricity when generated, we can find the amount of generated electricity in this voltmeter. Now these two electrolytes also connected by a salt bridge. Follow here, this is a salt bridge, and this salt bridge actually a U-shaped glass tube in which different salts are used, such as potassium chloride, sodium chloride, or sodium sulfate, ammonium chloride, etc. Here mainly that type of salt are used who the speed of ions are almost equal with the speed of cations and anions, which are used in anode and cathode. And the function of this salt bridge is mainly this salt bridge actually connects the two electrolytes to complete the circuit, number one, and another function is it actually maintain the balance of deficiency of cations and anions in both electrodes. So it has two functions. One function it connects the both electrolytes to complete the circuit, and another function is it balance the cations and anions in both electrolytes. How? Follow here. This is a anode and this is cathode. Now when electricity is applied and these two metal plates are connected with the positive end and negative end of a battery. This is the E of battery. So when electricity started to supply, then what will happen? Zinc From zinc plate, zinc releases 2 electrons and converted into zinc ion, and this zinc ion actually mixes with this zinc sulfate solution. Inside the zinc sulfate solution there is also present zinc ion. So from the plate, zinc releases 2 electrons and converted into zinc ion and mixes with this solution. Before reaction, inside the electrolytes, the amount of zinc ion and sulfate ion is balanced. But when zinc mixes with the solution as zinc ion releases 2 electrons, then the amount of zinc ion is increased, so balance is in that time it is not balanced. For this, from salt bridge, chloride ion comes or mixes with these electrolytes and balance the cations and anions. Like this way, when these 2 electrons released by zinc goes through the copper wire and reaches to the another electrode, that is cathode, then from the solution electrolytes, copper ion reaches to the electrode and accepts 2 electrons and converted into metallic copper. So here also ions deficiency occur, because from solution copper ion is converted into metallic copper through accepting 2 electrons and deposit on metal plate. So here deficiency of cation occur. For this, from salt bridge, cation mixes with the solution. Like this way, salt bridge actually balance the cation and anion in 2 electrolytes. And like this way also, from chemical energy, electricity is generated. That means in galvanic cell, chemical energy actually converted into electrical energy, like this way. And from a galvanic cell at standard condition, that means when we use 1 molar solution as electrolyte and temperature is kept 25 degrees centigrade or 298 Kelvin temperature, then its recorded volt or EMF actually electrode potential, electrode potential difference of both anode and cathode together is called EMF. EMF is recorded as 1.1 volt. So now we will know about EMF. EMF means electromotive force of a cell. The sum of oxidation potential of anode and reduction potential of cathode is known as EMF of the cell. It is generated by E cell and its unit is volt. So EMF of the cell actually anode potential and cathode potential. And if we also we can determine EMF from the oxidation potential of both electrode, anode and cathode, like this way. And also we can determine the EMF cell from the both reduction potential of anode and cathode, like this way. So we will learn more about this in next class, no problem. So that means we have to know about electrode potential. In that time it will be more clear to us. But you have to remember this to calculate different problems based on electromotive force. Now I will discuss about the presentation of different half cells or full cell, that is cell diagram or cell reactions, etc. For example, presentation of half cell. That means how can we write a half cell shortly. The touching layer, already in galvanic cell we have seen zinc metal is immersed in zinc sulfate solution. So the touching layer of electrode and electrolyte is expressed by an oblique or comma. That means when we will write zinc sulfate half cell, then we have to write zinc oblique zinc ion, that is zinc sulfate, that means zinc ion, or zinc comma zinc ion. And the half cell in which oxidation takes place, that is actually written like this way, metal ion. And the half cell in which reduction takes place, that is written like this way, metal ion oblique metal. So like this way we can represent the half cell. And also sometimes different inert metal like platinum, silver, gold are used for electrical connection, especially in case of gas electrode, we will say in next class. So in that time we have to mention the inert metal. Like this way, hydrogen gas electrode. Hydrogen gas electrode, there is used platinum wire to conduct the electricity, and also there is present hydrogen gas, and also hydrochloric acid or sulfuric acid, etc. So we can present oxidation half cell like this way: platinum comma hydrogen per hydrogen. That means we have seen metal per electrolyte. For this here we have to write hydrogen per hydrogen ion. And for reduction reaction we have to write what? Platinum, then electrolyte. There is actually both are electrolytes, but reduction, why? Because ferric ion through accepting electrons converted into ferrous ion. So ferric ion per ferrous ion. Like this way we can easily represent the half cell. Now we will know about writing cell diagram, that is full cell. So to write the full cell, we have to at first oxidation half cell, we have to write oxidation half cell, short form of oxidation half cell, then reduction half cell, and between them we have to use a bar, use a single bar. And if the cell is contains salt bridge, then in that case we have to put here double bar. Now total cell reactions. For example, in galvanic cell, what we have seen, in zinc electrode anode there is actually reduction oxidation occur and cathode reduction occur. So oxidation reaction will be what? Zinc releases 2 electrons and converted into zinc ion, and reduction half cell reaction will be copper ion accepts 2 electrons and converted into metallic copper. Now if we cancel the electrons from both sides, then adding both reaction we will get zinc reacts with copper ion, that is copper sulfate, and produces what? Zinc sulfate plus copper. This is total cell reaction. Like this way we can easily present half cell, full cell, and also cell reactions. And this is important because sometimes it may come in your exam. For example, write cell reaction and cell diagram of a cell with electrodes iron per iron sulfate and platinum comma hydrogen per sulfuric acid. That means here iron per iron sulfate, it is oxidation anode, it acts as anode because here metal per metal ion. And we know that also the position of iron is upper than that of hydrogen, so iron is more reactive than hydrogen, so iron acts as anode here. And hydrogen, this cell actually reduction half cell, so here this is not written correctly. It can be written like this way, but you have to rearrange. Here actually will be hydrogen ion per hydrogen, because we know that reduction half cell is write down ion per metal, ion per element. Follow here. Oxidation reduction half reactions will be following. So oxidation half reaction will be iron releases 2 electrons and converted into iron plus 2, and reduction half reaction will be 2 hydrogen ion from sulfuric acid accepts 2 electrons and converted into hydrogen gas. So adding these two reactions we will get iron plus 2 hydrogen ion, iron ferrous ion plus hydrogen gas. And cell diagram, how can we write? Oxidation iron per iron sulfate and double bar, and also sulfuric acid per hydrogen. Also you can write iron oblique iron plus 2, hydrogen plus oblique hydrogen. So my dear students, I hope you clearly understand today's lecture, and in next lecture I will discuss about electrode potential. This is also very, very important. So today up to this, goodbye everybody. Thank you.